All right. Hello, everyone. Thanks for joining us at 8:40 a.m. That's amazing. I'm Madison Bristol. I'm the 6PPD Stormwater Planner for Ecology. So I do all things internal and external on 6PPD and just working with lots of amazing folks and collaborating, make things happen, because that's really how we do any of this work on this super complicated and interdisciplinary issue. I do want to pass it. Just little. While we go through.
Hello, everyone. I'm Shelby Giltner. I'm 6PPD Environmental Engineer working with the Washington State Department of Ecology. So my world pretty much revolves around BMP effectiveness studies and determining what BMPs from our stormwater manuals can reduce and remove 6PPD.
And I'm Francis. I'm kind of the odd one out here. I work with the Stormwater Strategic Initiative mainly on marine water quality and wastewater, but I have been tasked with the side quest of 6PPD-Q work. So I'll explain more and what that means when it's my turn. Cool.
Awesome. So for today, what we have planned for you is we are going to give a little brief background on 6PPD, just in case you need that grounding. We're also going to go through our agency strategy because we have many different ways that we're trying to address this. Then we're going to focus in on the stormwater part of this, which includes the research, some available funding could be of interest to some folks, as well as policy making around 6PPD. Then Francis will give some great updates from the Stormwater Strategic Initiative Lead, or we'll call it the SIL, and the Transportation Charter Group. And then lastly, we're going to have a Q&A session. And so we want that one to be super just collaborative, bouncing around the room. We have some prepared questions in case there's any silence, but usually there's not too much silence for 6PPD. So we'd love just talking and discussing this issue. So to start with the background on 6PPD. So 6PPD is a chemical that has been added to tires since the 1960s, and it prevents the rubber from cracking. We have this image right here on the right. That is a tire without 6PPD. On the left is a tire with 6PPD. And you can see there's a lot more cracking. And some concerns around cracking are that it reduces the efficacy of the tires as well as the safety of the tires, potentially from tire blowouts on the road. And so it's important when we're thinking about this, if we're getting an alternative chemical in here, we also need one that performs safely and is not toxic at the same time. In 2020, this is where things got really interesting. There was many observed salmonid deaths previously to this, but in 2020, that's when the discovery of 6PPD quinone happened. And basically, 6PPD quinone forms when the 6PPD in tires react with ozone in the environment. Both are emitted from tires, and they are in all tires globally. So this is a global issue, but it especially affects our salmonids here in the Pacific Northwest. And it's acutely toxic to coho salmon. They are the most sensitive that we have seen. And so here's a nice map right here. And the species that are include brook trout, coho salmon, rainbow trout, and lake trout on this map right here. Blue is native ranges of all of these species combined, and the brown is non-native places that they have been potentially introduced or for fishing purposes as well. And you can see that is a lot of the watersheds in the United States. So a lot of these sensitive species are all across the United States. And then when we're looking at acute toxicity, we often talk about LC50. So that's the concentration at which half of the test population experiences mortality. And so we now know that coho salmon, it takes less than 100 nanograms per liter, which is just tiniest drop to cause mortality potentially within 3 hours. We also, this is brand new research, coastal cutthroat trout also have a very similar LC50. So we're learning more about the coastal cutthroat as we speak. Some other sensitive species include rainbow and steelhead trout, brook trout, and lake trout. Those all experience acute mortality or have an LC50 of 500 to 1,000 nanograms per liter. And then from there, the picture gets a little interesting because we have species such as Chinook salmon and sockeye salmon. They don't experience the same level of mortality or have that low LC50, but there is a data gap still of are there impacts throughout their life that we don't know about. So when we're talking about salmon, something that's really important are treaty rights. So we do know that salmon are vital to Pacific Northwest tribal nations, and the right to fish is an inherent right and has been reaffirmed through treaty rights and court cases. So these are some of the reasons why at Ecology we partner with a lot of tribes, and that's a really integral part of our work. We try to center this as much as possible. One of these court cases, and I should say many of these court cases, is US v. Washington, which is the same filing, but there's over 50 separate court cases under this, just continually refining treaty rights and clarifying those. You might know of the Bolt decision, which is a seminal case that really affirms some of these rights, and the right to tribes to have 50% of the fish in usual and accustomed fishing areas in Washington state. It also establishes the tribes as co-managers. So again, working with the tribes. And then some of the concerns that we've heard from tribes about this, and these are concerns that are also reflected by some other groups, but I really want to highlight these, are potential fisheries impacts, sublethal or chronic effects to the fish over their lifetime, human health impacts, food web impacts, how is it moving throughout the food web in different organisms, traditionally harvested plant materials, and also the fact that 6-PPD-Q might create a toxic barrier and it might be negatively impacting really important tribally led efforts such as reintroduction, hatcheries, and habitat restoration. So coming to Ecology and looking at what is our strategy, there are many different areas that this impacts. And so we have 4 main approaches to address this. The first is we're trying to reduce sources of 6-PPD and evaluate safer alternatives in tires. We do not want to implement a regrettable substitute in the tires. We're also mapping and monitoring to support stormwater planning. We're evaluating tire recycling and disposal impacts, some of those secondary products that can be produced from tires. And then last but not least, researching and implementing stormwater best management practices. So now I'm going to pass it off to Shelby to talk about some of these agency strategies briefly, and then focusing in on that stormwater piece.
All right, the next few slides, I'm going to go over Ecology's agency-wide effort at reducing 6-PPD and 6-PPD sources. A few of these slides are a little bit out of my lane of expertise, but we wanted to give you the full background of all of the work that Ecology is conducting. And one of the efforts is reducing sources of 6-PPD and finding a safer alternative for 6-PPD and replacing it in tires altogether. So we're doing hazardous criteria testing on different alternatives. The state has developed hazardous criteria for toxicity testing. So they collect data on acute toxicity to different aquatic species, including coho, rainbow trout, different animals or different aquatic species at different trophic levels. And then they also look at transformations of the transformation products of these potential replacements for 6-PPD to make sure that they are not toxic or have sublethal effects. If there is a safer alternative that exists, Ecology will recommend actions to advance safer alternatives. So hopefully we can replace 6-PPD in tires in the future. So these are very preliminary results, but these are alternative chemicals that Ecology has been researching to replace 6-PPD. This includes CCPD, which currently has not passed the toxicity testing criteria. Our hazardous waste department is running these toxicity tests. They're also looking at different PPDs, including 7-PPD, IPPD, and Durazone 37. These chemicals have not failed toxicity testing yet and are showing to have good rubber performance. So we do want to find a replacement for 6-PPD, but we do have to understand that it has a very important safety component in our tires. So we have to make sure we're replacing it with something that has as good of performance. They've also looked at graphene, which is a component of graphite. This is a type of example of a chemical that we could remove some 6-PPD from the tire if we used it, but not all of 6-PPD. And as we know, the transformative product 6-PPD-Q is acutely toxic at very low concentrations. So even having some 6-PPD in the tire is not the best alternative. So in addition to those alternative assessment studies, our environmental assessment program, our EAP program, is looking at mapping and monitoring to support stormwater planning. So one of our biggest challenges is understanding where 6-PPD quinone can be found at detectable concentrations. So the geographic scope of the tire and road contaminant problem is really expansive. 6-PPD is ubiquitous. There are tires and roads all across landscapes. So it's a really large, extensive problem. So they're doing mapping to look at different things like vulnerable areas based on traffic, land cover, and salmon distribution. This map right here shows some of the hot spots. The darker colors indicate where there is more roads, more impervious surface, rain patterns, traffic, and vulnerable species are located. So we're partnering and funding studies to help develop additional mapping tools, as well as conduct sampling and site assessments to determine what type of concentrations are in these hotspot areas. So the assessment strategies, this involves environmental risk assessment. So going out and collecting data from receiving waters. There's several different methodologies that they're using to do that, including using passive samplers. Later today, there's a presentation on using passive samplers and receiving waters. They're trying to determine when and where the risks of vulnerable aquatic organisms are highest. We want to know where the concentrations are highest. We also need to understand how long toxic concentrations of 6-PPD persist in the environment. Okay, so yes, assessment strategy. Basically, this is collecting, sampling, and monitoring and receiving water so that we can understand where the concentrations are high, where we can focus our stormwater efforts. And there's a lot of coordination trying to partner with the existing monitoring programs to add in 6PPD-Q as part of their monitoring programs. We'll go into that a little bit more here in the next slide. This is an example of a data set from several storm events and time intervals. The black dots represent outliers. These areas down here, these are high urban, so more impervious surface. So we're seeing what we would expect, higher average concentrations of 6-PPD quinone in receiving waters. The outliers go as high as 500 nanograms per liter. And then we move down here, this is a low urban residential area. We're seeing lower concentrations, less fluctuations in the concentrations. This is a really interesting data set right there that is actually collected from downstream of an area that's receiving stormwater treatment. This is a highway outfall that has treatment, a treatment train that includes a constructed wetland, grassy swales, and a retention pond, I believe. So you can see with some sort of treatment, we're seeing lower concentrations, which is a really interesting data point, an area of study that we want to pursue. This next slide is an example of concentrations during a moderate storm event. So you can see the peak concentrations are very close to that LC50 for coho salmon. This blue dotted line right here is 12 nanograms per liter, which is the state's adopted aquatics life criteria. So you can see for a large duration of the storm, the concentrations in the receiving waters are above that. We'll go into the aquatics life criteria here in a few more slides. So in addition to advancing mapping and monitoring efforts, Ecology is also assessing used tire assessments. This is a study that's being conducted currently. The final report for this should be coming out here shortly. But to look at the whole life cycle of a tire, how it's being reused and recycled, are there alternative products that we need to be exploring as sources of 6-PPD quinone? What communities are being most impacted by used tire recycling programs, and looking at our state agency policies to determine if there are any policy changes that we need to make. You can scan this QR code and it will link you to a PowerPoint presentation that highlights that used tire assessment. And again, the final report should be out here in the next month or two, I believe. Okay, back to stormwater BMPs. This is my comfort zone. I feel much better moving into this slide deck. I don't even need the notes. No, I probably do. So stormwater BMPs. So back in 2023, the Washington State legislator, which for some reason is a really hard word for me to say, I always feel like I'm saying it wrong, legislator. They tasked us and funded us to study stormwater BMPs for their ability to reduce and remove 6-PPD quinone. At 2023, there was still very little that we knew about 6-PPD and 6-PPD quinone. The chemical was just discovered in 2020. But in 2022, the Department of Ecology released a BMP effectiveness report that was worked on by several different funding partners, including Amy that's sitting back there. And they did a literature review that looked at all of the existing chemical and physical properties of 6-PPD and 6-PPD quinone. As you can imagine, newly discovered chemical, there wasn't a lot of readily available information, but based on what they were able to find, they ranked and prioritized stormwater BMPs from stormwater manuals from Washington State and several manuals across the country for their high, medium, and low potential to reduce and remove 6-PPD quinone. And they also developed a whole list of data gaps of information that we need to pursue and understand to really know how effective these BMPs are going to be. So great, 2023, we get funding, go out, sample BMPs for their effectiveness. Well, this is a bit challenging, a difficult task, as many of you in this room know. Stormwater BMPs, for one, are not designed to be sampled and monitored. A lot of times they're installed in the ground. Either the water infiltrates or evaporates. You can't access an influent and effluent. These devices and different types of management practices aren't meant to be monitored. So collecting data can be very difficult. Also, as a state entity, we don't own any stormwater BMPs, so we really depend on partnerships with different entities who do own them to be able to collect data. You also have to do event-based sampling, storm chasing essentially. So collecting data through the whole cycle of a storm is very difficult to do. It requires a lot of expertise and knowledge in collecting data, storm data. And of course, it can be unpredictable. Storms can hit in the middle of the night. You have to have staff that can go out and do that type of work at all hours of the day, which can be very challenging. And then capturing representative samples for BMPs over the life cycle of their BMP is also very difficult. A BMP can be very effective when you first install it, but will it be as effective 1, 2, 3 years down the road? Or what is the maintenance schedule? How does that impact its effectiveness? So to really understand how effective BMPs are, we need to have a really large data set. And then again, we're working with a contaminant of emergent concern. Standard sampling methods and analytical methods haven't been developed. What type of bottles we need to use, what are hold times, analytical methods. You can't just send a sample off to any lab and get analysis for 6-PPD quinone. There's only a couple of labs that can run that analysis. It's very difficult to do. It requires very expensive equipment. So currently, we have a few labs that have accredited methods for 6-PPD quinone now. That includes Manchester Environmental Lab, King County Environmental Lab, and UWT. The EPA has drafted a draft method for 6-PPD quinone in water. It has not been finalized yet. And then there are several labs working on sediment methodologies, including one I'm going to highlight here in a second. So despite all of these challenges, we were still able to fund over 20 different research projects in the last biennium. These research projects are focusing on these priority data gaps that we took out of a very extensive list of data gap around 6-PPD quinone. First off, we're trying to understand stormwater characterization. So to understand the influent concentrations of 6-PPD quinone that are coming into these BMPs. How does land use, traffic density, and impervious surface impact those concentrations? We're also testing high potential BMPs that were ranked as high potential in our literature review study, the BMP effectiveness report, things like street sweeping, bioretention soil mixes, different proprietary devices to determine how effective they actually are. This is a data graph, the crumb rubber mulch and turf. We get a lot of questions about that. Recycled tire products are used in turf fields. There's been a lot of questions about if these turf fields are leaching 6-PPD quinone. So we do have some studies looking at that. We're also trying to understand the fate and transport of 6-PPD and 6-PPD quinone. We still don't know a lot about it and how it's moving through the environment. So we need to have a really good understanding before we can make recommendations or even requirements on how to treat and remove 6-PPD quinone, and then developing sampling and analytical methods. These methodologies don't exist. We're still developing them. It's a very time-consuming process to have analytical methods so that we can have standardized quality data. So another QR code, it has this cute little dinosaur in the middle. I don't know why that is, but if you scan that, that will take you to our website. It will show you all of our 20 projects. We try to post all of our deliverables up there as soon as that we can get them. There's so much information out there. We want to try to be able to share it as quickly as we can. So I highly recommend going to the site. It shows all of our funding partners that we've worked with. That includes the Stormwater Action Monitoring Program, the Stormwater Initiative Lead, the SIL. We also partner with our Combined Funding Grant Program to try to tack on as much 6-PPD-Q monitoring as we can to already existing projects. The project contacts are also listed on this. So if there's a specific project that you have a question about, you can email the project manager. So highlighting today, we have a whole day of 6-PPD. I'm super excited about it. I don't know about everybody else, but I'm pumped. These are all of our funding partners that are going to get to go into detail on all of their really exciting research projects and some of the latest and greatest findings and data that are out there right now. So I highly recommend trying to hop into some of these other presentations today. And you'll hear everything from developing sediment method that the City of Tacoma has done. We have several bioretention studies, a granulated activated carbon study. So a lot of really good work with all of our funding partners. We appreciate them so much. That's my sad. This slide makes me a little sad because I really like to talk about all the studies and the results and the data. That's what I like to geek out on. And I didn't want to steal anyone's thunder today or like spill the beans on all the findings, but I had this slide in one slide that had a little summary of the results of all the work that we've been doing over the past 2 years. We've done a lot of stormwater characterization coming out of the I-5 Ship Canal Bridge. We have a lot of data on the influent concentrations at that particular site. And we're seeing average concentrations from 600 to 700 nanograms per liter coming off from a high traffic urban area. So that's well above the LC50 for coho salmon, high concentrations. We've also been looking at different BMPs for their potential effectiveness. We've had some really high success with bioretention and high performance bioretention soil media, as you saw in that really great video today. And there'll be several presentations on that this afternoon and throughout the day today. We have a granulated activated carbon study that went with Pierce County that had very successful results. They have a really unique decant facility that River One will go into later today. These BMPs are showing to have effective components, and we still need to gather more research on full-scale sites and facilities to really be able to see how well they're working under environmental conditions. We also have a column study that, interestingly enough, is just looking at unamended soils that so by columns, these big columns like this picture right here are packed with different soils that don't have any treatment. They just meet our site suitability criteria in our stormwater manual. So they have a certain percent organic and a certain infiltration rate. And preliminary results are showing that even these unamended soils can be effective at sorbing 6-PPD quinone. We had a study ran by UWT that looked at just components of engineered media. So all of the components of bioretention media, like they looked at just the compost and just the sand. They looked at mulches to determine what type of media is individually absorbing 6-PPD quinone. And that confirmed that things like biochar and compost and even wood mulch could be effective at sorbing 6-PPD quinone. And then we have studies that are developing standard operating procedures for 6-PPD quinone sediment. So that's my one slide where I got to go through really quickly some of our exciting results, but I really highly encourage everyone to listen to some of the presentations throughout the rest of the day. And now I'm going to hand it back to Madison for the exciting funding. There it is.
There it is.
Oh, I'm going to give it the microphone.
So we do anticipate receiving some new research funding. So we do want to support lots and lots of new projects coming into this next biennium. And this will be, again, from the Washington State Legislature. So typically how we do this is through interagency agreements. So we partner with public organizations and tribal governments. Non-public organizations like contractors, there is a way for them to be involved, and often that's through a subcontracting process with the people that we contract with directly. But unfortunately, with the IAs that we have or the interagency agreements, we can't always do that. We are starting some conversations now about this funding. So if you're interested, please contact us. We are prioritizing project pitches, and pitches can be just one-pagers or conversations that we're receiving from now until June. And we're also prioritizing projects with partners that are tribal governments as well, led by or partnered with those. We have $2.9 million available at this point. And we hope to support anywhere between 5 to 15 different kinds of contracts. And the duration of the projects will be from July of this year until June of 2027. So that's about 2 years of projects. And if you're interested, you can email me and I will set up a time for us to just have a brief conversation and see if this is a good fit for the funding, or whatever idea that you have would be a good fit. And so here are some things at Ecology that we're kind of thinking about with possible research topics. And if you have an idea that's outside of this, we would definitely still be interested to hear what that idea is. But something that we're interested in is field testing BMPs. We want to look at testing already installed BMPs and treatment trains in the field. One of the reasons for this is that with 2 years of funding, installing BMPs and then also assessing them, we don't have enough time to do that. So, and we also, as Ecology, we don't have access to a lot of these sites. So that's really where the partnerships come into play. And then we can test these BMPs in the field. We love to do that. The treatment trains were also really interested in that. Shelby mentioned a data point earlier of an area that had multiple BMPs and the receiving water concentrations were really, really low in a high traffic area. We want to look at more systems that are kind of like that and see how they're working because there's some promises there. We're also looking at BMP maintenance and cost effectiveness. We need to look at ACART with this and make sure that whatever we're kind of recommending also is reasonable and potentially has some low cost. And we want to ensure the long-term effectiveness of these, especially if 6PPD is kind of this awesome catalyst right now to install a lot of BMPs. We want to make sure that whatever is installed is also long-term being effective. We still want to look at some stormwater characterization. Something that we still need more data on is different land uses and concentrations coming off of those land uses. We have a good idea from some high traffic areas, but when it comes to rural areas, we don't have a lot. Commercial areas, industrial areas, just different kinds of land uses. We're still trying to figure that out. And that's really helpful for us to develop some guidance around managing 6PPD quinone. And then lastly in this list, we want to look at the fade and transport. We want to better understand how 6PPD-Q moves through and persists in the environment. This has some linkages to hazardous waste and disposal of any kind of, say, bioretention products as an example of this. So we want to learn how this is moving through the environment because we still have some data gaps there. So what is the end goal of all of this work? Something that we're especially going to be focusing on a lot in the next 2 years is developing usable guidance for permittees, communities, and regulators, and synthesizing all of this great research that we've been doing and really communicating the kinds of BMPs that can work in different areas for specific kind of land uses. So that's a really, really big task, but that's something that we want to accomplish in the next 2 years. And we're going to be spending a lot of time on this area. And essentially what that guidance is, we want to produce some kind of guidance document, and that can be supplementary to the stormwater management manuals, as well as the municipal stormwater permits, as well as other permits as well that we manage. We also want to continue sharing our research publicly. So that research page that was shared earlier, we're just going to keep adding to that. There's over 20 research studies on those. We're going to continue to make sure those deliverables are very public. And so with that, that brings us to our stormwater regulations and rulemaking. So tying this into what are some of the things we've already been able to accomplish, even with all the data gaps that we have. Ecology has delegated authority to issue Clean Water Act permits. So some of the ways that this is looking like right now is the reissuance of the municipal stormwater permits and manuals last year. This reduced some project thresholds in terms of acreage, retrofits, as well as street sweeping requirements across the entire state. There's some really great work that's being led by the Washington Stormwater Center, as well as Evergreen H2O, about creating a street sweeping manual and working with permittees to actually make sure that that is implementable. Some really great work. There was also the reissuance of the industrial stormwater general permit last year as well, and this includes monitoring and reporting for 6PPD quinone. It does not include any standards or limits. And then lastly, there's also a draft Washington Department of Transportation stormwater permit that will be published this fall is the anticipated timeline for that. So look out for that. And with the aquatic life toxics criteria, that was also developed last year as well. So Ecology and the state of Washington have adopted an aquatic life toxics criteria for freshwater acute mortality. This does not include saltwater, chronic or acute effects, or any sort of chronic or sublethal effects in freshwater environments. Right now, where this is at in the process is that Ecology adopted the rule last year and submitted it to the EPA for review and approval. And the next step is Endangered Species Act Section 7 consultation, and that is with NOAA. And we will see how that goes. But essentially with Washington, this is 12 nanograms per liter is that limit that we're looking at. And that really is to protect the most sensitive species, which at this point is especially coho salmon. Okay, and I have this QR code right here. For anyone who is interested, one of the best ways to stay informed is to join our listserv. So this will take you to a link to kind of sign up for the listserv, and we send out, depending on what's going on, quarterly to monthly listservs about all things 6PPD, and that includes stormwater as well as the other subject areas we've been talking about. So with that, I'm very happy to pass it off to Francis to talk about their science, as you said.
Yes. Yeah, like I said, I'm Francis Bothfeld. I work with the Stormwater Strategic Initiative Lead. We're just gonna call that the SIL. I usually, or was tasked originally with working on nutrient pollution in wastewater, which then turned into CEC's contaminants of emerging concern in wastewater. And then they're like, oh, contaminants of emerging concern, and you have a background in stormwater and soil science. So that's what my master's was in. Welcome to the 6PPD-Q world. I still do the other two, but it's kind of a bit of a all hands on deck when it comes to 6PPD-Q, as you can imagine. So this has been a really fun side quest, I guess. So I'm just gonna go over what the stormwater SIL is briefly. It's kind of complicated, but just so that people understand where the role it plays with, especially with this team and at Ecology. Our projects that are current, past, and recently funded. And then I have like a side quest of a side quest, which is the Puget Sound Stormwater and Transportation Charter Group. So I'll just go into what we're doing there, why it exists, and what we hope to accomplish. So we'll start with the SIL. What is the Stormwater Strategic Initiative? So it's part of the National Estuary Program, and it's one of 3 initiatives charged with bringing people together to tackle issues that are critical to Puget Sound. The 3 are Habitat SIL, Stormwater SIL, and Shellfish SIL, and together we put our arms in, and we are Captain Planet, or Captain National Estuary Program. So I specifically work on the Stormwater SIL. We have a pot of funding that we give out as grants, but we also do a lot of strategic planning as it relates to that funding. So we really work around these implementation strategies. So the bottom here is how the implementation strategies work. So going from the initial state to the overall goal, what's the pathway that we need to get to be able to solve the problem. This is obviously a very simplified version of it. We have 3? Yeah, benthic integrity and biological index, BIBI, toxics in aquatic life, or some people know it as toxics in fish, so TIF, and then marine water quality, which is usually what I work on, but I also play zone and do a bit of toxics in aquatic life. And so it's when you actually look at the implementation strategies for all 3 of these, they're 3 separate things and they are absolute spaghetti. But if you can pick through it, that's how we figure out like what we need to fund, or what projects we want to work on. Some of them are fundable projects, so like giving people money to solve a problem, and then others are more policy related stuff, where it's less funding and more just sitting down and thinking really hard on how to solve a problem. So we really lean on our advisory team to help us really pinpoint the issues that a small pot of money can fund. We are not really afraid of taking some risk when it comes to funding things, because our projects they can be a little off the wall, a little bit different than some of the other funding that's like from the legislature that is pretty prescriptive or can be pretty prescriptive. And so we really look for those projects where like just a little bit of push will get them going. They just need like a little bit of catalyst. So we try not to be too duplicative with our funding. That being said, we do fund some 6PPD-Q work that is going to sound very familiar, because as I mentioned, we're kind of all hands on deck. It's kind of hard to ignore 6PPD-Q as an issue, or not think that like a little bit of funding here will make it or be catalytic. So we do fund some 6PPD-Q stuff along with like a lot of very different things. So, and luckily we work really well. We're in the same unit? No. section, that's the one. We're in the same section and have meetings, and we work really well together. So the projects that are funded under SIL can really inform some of the work that our 6PPD-Q team is doing. So here's a list, and it's, well, I mean, it's not the 20 that they've explained. It's there's only 9, I guess. And there's one, this one is being presented today from King County. I'm going to go to that. I'm really excited. We also have 3 new ones, new as in we're still going through the scope of work. So the Seattle and King County Public Health with looking at PPD derivatives and PFAS in fish consumers. So that's, I mean, obviously incredibly different than stormwater, and looking more at the human health side of things. And then the efficacy of currently installed stormwater conveyances to remove 6-PPD quinone. You might have just heard saying that they want to work on that as well. So like I said, there can be some overlap and we work well with the team. And then also a NOAA Northwest Fishery Science Center project as well. So I'm going to point to at least one of these out because I'm going to reference it later, but the multi-criterion decision tool, which will be presented today at King County. We also have another one that's not up here because it's technically not 6PPD-Q, but they are working on 6PPD-Q stuff, which is like a mapping and prioritization for BMP installation in Thurston County. So, which will have potentially a 6PPD-Q layer to it. So here's the Stormwater and Transportation Charter Group, my side quest of a side quest. I really want to figure out how to make a Lord of the Rings joke, but I don't know it well enough. So this is kind of a complicated, okay, so this is a Puget Sound Federal Leadership Task Force Working Group and committees and Tribal Treaty Rights at Risk Initiative. This is kind of how they're organized, though there's not really arrows between them. But we're down here. We were formed out of the Puget Sound Federal Leadership Task Force, specifically to look at stormwater and transportation. So this task force is a tribal, state, and federal federal, tribal, state charter group to look at stormwater. And so here are just a few of the folks that are involved in this. So EPA, NOAA, USGS, not so much FEMA, but a little bit Forest Service sometimes, Ecology, WashDOT, and then a few tribes as well. PSP is in there as well. Puget Sound Partnership is in there as well. We have 2 projects that we're working on. These are, this is unfunded. So this is like the sit down and think hard type of stuff. Be creative. So the first project is the low risk, high reward project. This is not my project, but I will talk as eloquently as possible about it. We have maybe someone in the room that knows a bit more, but this is looking at BMPs and then using the data surrounding BMP effectiveness to model input, predict, and then output, and then apply the results for predictive planning to eliminate toxic constituents in stormwater. This is mainly with 6PPD-Q, but generally, if you throw something through a BMP, other things come out too, which is great. So originally there was going to be some funding behind this, and so it was going to be more of install BMPs, see how effective they are, use modeling, and then extrapolate from there. We had to get a bit creative. I can go to the next one. We had to get a bit creative because funding kind of dries up sometimes. We specifically also we're going to, not me, they are looking at using Seldom, working with USGS to use Seldom and the model output. One of the things that they're especially interested in, or one of the reasons why this project really came to be in the beginning, is the potential for ESA consultation. And using this for ESA consultation, because I know that ESA consultation, when putting in BMPs, can be really time consuming and really cause a delay or pause in BMP installation, which we don't really have the time to do that. Fish are dying right now, maybe not as we speak. It was raining this morning. So, yeah, so trying to really speed up that process, potentially speed up that process using this tool that they are developing. So like I said, in the beginning, it was going to be installing BMPs, seeing, and then using the understanding the BMP effectiveness and using that data. They've now kind of transitioned to more opportunistic site selection. So something similar to what Madison was talking about earlier is stuff that's already installed, seeing if we can use the data the 20 projects, 20 plus projects, seeing if we can use the data from that to help develop the model. And then we could have, it would be an iterative process where understanding what happens, we can maybe choose better sites or have different sites with BMPs and stuff like that. So, and then incorporate lessons learned. So it's a pretty cool project. And yeah, so here's the timeline for that project. Yeah, so we're really just at the beginning. So, and then the next one is the prioritization framework, which I'm more involved in, which is also at the very, very beginning. So I pointed out those two projects, or I mentioned one, pointed out the other, the multi-criterion tool from King County, and then Thurston County also has a prioritization framework that they're working on. Both of those were about $500,000 of project funding to develop. We don't have $500,000 for every single community or entity that would like to do a prioritization framework. And, you know, sometimes they're smaller, or the community is very small, so they don't necessarily have the expertise either. So this prioritization framework is really looking to create some sort of tool or just a like talking points so that they can use that as like a tool in talking with folks that are making decisions. So this would be a watershed scale prioritization. So the goal is to identify transportation retrofits that reduce 6PPD-Q, but also increase adult salmon returns. So this is at a watershed scale. We're not trying to, this isn't going to be a whole Puget Sound thing where we pit different watersheds against each other, trying to prioritize the entirety of Puget Sound. That doesn't really work, and it can lead to some strife. And the idea is to identify high loading roadways and parking lots. And then the next bullet point is really important, is tap into local on the ground knowledge to identify opportunities with an emphasis on coho salmon returns. So really centering tribal treaty rights there. And then, but really tapping into that local on the ground to figure out where the overlap of 6PPD-Q dosing is with salmon bearing streams, or salmon rearing habitat, specifically coho rearing habitat. The reason we're thinking about doing this is not all roads are created equal. So not all roads contribute the same levels of 6PPD-Q, and not all roads are owned and maintained by the same entities. And then on top of that, not all habitat is created equal. So some habitat has a larger impact within a watershed. And in some places, habitat is limiting production. So it doesn't even matter. If we were to solve the 6PPD-Q or the stormwater issue in that habitat, we still wouldn't have coho returns because there's a whole host of other issues. So we're like really using the not all habitat is created equal, not all roads are created equal concept, and using it to our advantage to identify the low-hanging fruit, to prioritize areas where BMP installation would be great. So like I said, to figure all of that out, we want to go to the people that know the watershed. And this is another reason why we wanted to do it watershed by watershed, because it's like highly regional. We don't really have good data on coho rearing habitat, or at least we haven't necessarily found it. It could be wrong. I am not a salmon biologist. So really, like, we might even go analog here, sitting down with a big map and highlighting it with the folks on the ground that know what's up. And using just like 6PPD-Q data that we already have. So we've had a lot of interest from multiple jurisdictions. And then there is the potential, though I haven't really talked with a lot of them, so surprise, integrating habitat considerations into self-funded prioritization projects. These are the four that we have, the prioritization projects. and then creating a white paper guidance or, you know, making an appendix in what they're writing. So I guess, I'll put in a plug for if there is 6PPD-Q work out there that's being done and you think you have a data set that could be fed into a model or could just want to talk to the USGS folks on that, let me know. I think we've kind of scoured the internet and found all of them in this region, but who knows? And then if you're a region that might want to partake in this, and the first couple that I do might be a little bit of like a guinea pig. You might be a little bit of a guinea pig, but I'm great in a meeting. It'll be great. It'll be fun. And then so I can, you know, start working on a process that could go well in the guidance. So that's all I have. But we have time for questions. My email is wrong, but that's okay. It's Princess. Yeah, no, it's okay. I just forgot that. We're good.
Okay, everybody. Thank you to our presenters. That was amazing. Sure you all got every single acronym and initialism there, and it all made total sense. But I do want to emphasize that one of the ways we set up this event today was to have breaks in between these sessions, so you can find the presenters, you can talk in the hallway, you can exchange business cards and emails, and really get involved in the work that they're doing here. But we do have, we can go a little bit over time. We can take some questions. In the meantime, I'm going to need to see of our 11 chats, how many of them are just people being grumpy at me for not being able to see the screen. And then we will close out this session today, get back on track. So if you have a question, you have to use the microphone so the 15 people online can hear you. Go ahead and raise your hand and I'll bring it to you.
Oh, I did it. Sorry to everyone online. I just figured out how to fix that. So.
There's definitely studies going on about human health impacts. The Department of Health is leading several studies, but currently there's not an MCL or any other water quality standards other than that aquatics life criteria of 12 nanograms per liter. So human health impacts are still ongoing research. That's outside of the realm of what we do. We look at stormwater, but that work is being conducted.
There are some subject matter experts on this with the Department of Health. Eleanor Fanning is one of those, as well as Mallory Little. So if you want to reach out to them, their email is just their name, like mallory.little@doh.wa.gov. They're fantastic, and they do have some data on drinking water that could be interesting.
Absolutely.
So the question was about the SOP for 6PPD and sediment, and just to speak to it.
Absolutely, I can do that. There's a whole presentation on that today. We did provide funding for the City of Tacoma to develop a sediment SOP, and Manchester Environmental Lab also has a sediment SOP that's newly developed. We're just starting to get data using these SOPs. If you go to our website, the City of Tacoma and Tom and Fatima are back here who led that study. Their SOP is actually posted on our EasyView website. I posted that QR code if you want to read through it. So we're just going to be able to start collecting that data here in the near future as we have these methodologies, but there's nothing at EPA level. EPA doesn't have a method yet. These are just individual labs developing their own standard operating procedures.
One other addendum too is we mentioned accredited labs as well. City of Tacoma actually was accredited just a few days ago. So we now have 4 labs, which is fun. Good job, City of Tacoma.
But back to the question, are there any studies going on looking at the transformation products of 6PPD and 6PPD quinone? So is 6PPD quinone transforming into any other, I know the UWT is leading some studies on that to look at the transformation products. That's a really important component of this. We want to make sure that 6PPD quinone is not transforming to something more toxic, especially if we're going to be looking at BMPs that use infiltration or absorption like bioretention media. We want to make sure it's not breaking down. I don't have that data off the top of my head, but I believe UWT is the source for that at Ecology's lab, who
discovered 6PPD and 6PPD-Q. You have anything?
We do have a project with EA Engineering, which is really interesting. They don't necessarily identify what 6PPD-Q is breaking down into, but they have unamended soils in a controlled environment. And the 6PPD-Q is decreasing in concentrations over time. So potentially a next research topic is like, what exactly is happening there? Is it aerobic or is it microbial degradation? Is it something else going on? We have some questions.
I'm gonna finish off here because we're running back on time, but I have a question for the panel, and I'd like this to carry over to our conversations for the rest of the day and the other presentations. When we think about this problem, it seems really daunting. It seems like a huge challenge, but I do think from what I've just seen in the last 5 years that there's a chance we solve this in our professional careers, or at least in our lifetimes. So I'm wondering if the panelists can speak to what the big next steps are to move us towards that solution.
Yeah, I'm usually not like a glass half full type of person, but I definitely see this as a huge opportunity. There's a lot of, there was more energy, now a little less, but there is a lot of energy around solving this issue. And just generally when something as like spectacular, and I don't mean spectacular in a good way, but spectacular as fish going belly up and dying in this like kind of horrific death, the visual makes it a lot easier to like push for more funding and push for like more work when it comes to 6PPD-Q, especially as it is tied to tribal treaty rights. So I personally see it because, like I said earlier, when you throw some stormwater through a BMP, other things also come out. So it could be a catalyst for working on other issues as well. Then on top of that, layered on top of that, I see Washington State as being kind of a leader when it comes to 6PPD-Q. My like little inside CEC joke is that we're gonna be what Michigan is to PFAS. So people will be coming to us for questions, which I mean, I'd be really proud of that, and we can really help other states. And we're already starting to get those questions. I get those questions from New England randomly a lot, and we pick out New England about, hey, what are you guys doing and what should we be looking out for? So that's my glass half full, but.
Absolutely. I think that was a really good summary. I sort of forgot the initial question. Question, where we're going heading. I was really hoping to guidance. Yes, I was hoping that we would be able to do more Q&A. I have forced some of our funding partners to come here this morning because I really wanted to crowdsource all of the experts. I mean, some of the leading experts are sitting in this room on this topic to make sure that at the Department of Ecology, we have received this additional biennial funding. Are we heading in the right direction to getting to what we need? I think our big time goal is that we need to develop some sort of guidance. We need to resynthesize all of this information. There's so much data going on in science and research. Are we still addressing the right data gaps? And how do we get to, you know, the long-term lofty goal? And do I say it out loud? Do we get to a treatment standard that we need BMPs to get to for 6PPD-Q, and how do we get there? I was hoping we would have some time to kind of crowdsource that information today, but please come and talk to me after. I want to hear your thoughts and ideas. But one of our big goals from this biennium is develop guidance and recommendations based on the information that we have. Are there BMPs that we can recommend with the data that we have? I think we have some leaders that we will be able to. I think we're still going to need data on a lot of other BMPs, but I really want to get feedback if we're heading in the right direction.
And I'll comment on the non-stormwater world a little bit, making sure we're looking at the bigger picture of this as well. So looking at alternatives in tires, there was a tribal petition to really push for the removal of 6PPD-Q in tires, or 6PPD in tires. And we want to make sure, like, keep putting the pressure to make sure that that is being honored and we're actually able to put a different thing in tires or come up with different kinds of solutions, like alternative transportation options, just being really, really creative when it comes to transportation as an issue that we all manage to face. And then also keeping an eye on the human health impacts as well. I think there's a lot of really interesting emergent data on this, and that could open up potentially a whole other world of this issue that we haven't quite been able to address yet because we don't have the data on that. So that's really, really emergent, and just making sure that we're keeping our eye on all of these parts of this issue, the tribal treaty rights, the environmental justice impacts that could be connected to any sort of human health issues as well, just keeping our whole eyes on this. Something that is encouraging is that we have a lot of work, especially with the US Tire Manufacturer Association, which is a conglomeration of many, many different tire organizations. And they are very collaborative when it comes to this and looking at alternatives. And then we also have the piece of accountability and making sure that any of those proposed alternatives would actually be good alternatives. So just kind of keeping pressure on all of these different areas and keeping momentum in this catalyzing topic that we're all kind of trying to solve together.